All right, this is quiz 4 for Physics 151. This is actually spring of 2013. So the sonic boom can break windows. What is the mechanism that allows a sound to do this damage? That's due to the superposition of waves that causes these sonic booms. It's like also a duck traveling through water. We talked about this example. I have a duck, that's sort of a duck, traveling through water. It creates these waves, and then along the bow it gets this superposition of waves, and a plane does the same thing. When the wave generator, the duck or the plane or whatever, travels faster than the speed of the waves, then you get this phenomenon where you get this superposition of waves. What would happen if a loudspeaker box were built such that it resonated well at the audible frequency of 300 hertz? All right, so it resonates at the frequency that you hear. So the music would actually cause the box to resonate, and in that case, the box would vibrate. That's very much like the box that I passed around in class, the wooden box attached to the tuning fork that caused the box to vibrate at the same frequency as the tuning fork, because that was its resonant frequency. Sound is what type of wave? Okay, it's not a hand wave or a water wave. It's not a transverse wave. Remember, that's a wave that looks like this. It's a compressional wave where you get high pressure followed by a low pressure followed by high pressure, low, high, low. It's like compressing a spring. You get these high and low pressures. You're 3 meters from a speaker. You move to 6 meters away. By what amount is the intensity of the sound that you perceive changed? Well, intensity is power over area, and area is equal to 4 pi r squared. All right, so it's proportional to the distance squared. And so if I move twice as far away, then it's going to be 1/4 the intensity, 1/4. Consider this logarithm. Log of 10 to the x is equal to 10,000. All right, what is x? Since there are four zeros there, x is equal to 4. The speed of sound is about 300 meters per second. Bat emits a sound that travels to an object. So here's my bat. It emits a sound that travels to some object over here, goes there, comes back again. I want to know how far away is this object. I'll call that x. X is equal to v times t. All right, my velocity is 300 meters per second. And it requires 0.1 seconds. Now, be careful, because this 0.1 seconds is the time to go there and then come back again. So I'm actually going to use half that time, so 0.05 seconds. And 300 times 0.05 is 15 meters. When a source of a sound wave moves towards an observer, the pitch of the sound is perceived by the observer is higher. It's a Doppler effect. Which of these affects the intensity of sound? Okay, the distance from the source, reflection, attenuation, and the non-uniformity of source. Those all apply. Sound wave travels at 300 meters per second. The frequency of the wave is 600 hertz. What is the wavelength of the wave? All right, so the speed of the wave is equal to the wavelength times the frequency. I want to know the wavelength. So that's the speed over the frequency. That's 300 meters per second over 600 hertz. So that's a half. C is number 9. Sound has an intensity of 10 to the minus 6 watts per square meter. What is the sound intensity in decibels above the threshold for the theory of humans? All right, so the number of decimals is equal to 10 log of I over I naught. That's equal to 10 log of 10 to the minus 6 over 10 to the minus 12. So that's 10 log of 10 to the 6, 60 dB. What type of interference are these exhibiting? Peaks are lining up with troughs, so that's destructive interference. What is the period of this wave? That's the time to get from there to there. That's from 3 seconds to 6 seconds, so the period is 3 seconds. Number 12 is B. What is the frequency? The frequency is 1 over the period, 1 over 3, which is 0.33 hertz. What is the amplitude of the wave? The amplitude is the distance from here to here. That's from 0 to 2 meters. So the amplitude is 2 meters. And here I have two frequencies that come together, 300 hertz, 310 hertz. What is the frequency of the beats? Is going to just be the difference, 310 minus 300. So the frequency of the hertz is 10, excuse me, the frequency of the beats is 10 hertz.